All right, welcome. So today we are going to be going over our data. I don't want to take a tour. Okay, so we're going to be going over our data that we gathered in class today. Oh, that reminds me. Let's go back here and edit this. So we did a predator-prey lab simulation in class yesterday, and I'm going to help you guys analyze the data. So you remember, as scientists, not only do we make observations, but we analyze data as well. That's good. So we're only going to do 2 rounds. I originally said 6, but that would take way too long. Some classes barely even finished 1 round today. All right, so we're going to look at a group's data that did it yesterday. So we're looking at the data right here. So when they added 3 bunnies and 1 wolf into their meadow, 1 bunny died. The wolf ended up dying because it needs 3 bunnies to survive, but a new wolf migrated into the system and we started again. Those 2 remaining bunnies that were left lived and started to repopulate. And so here we had 2 bunnies left, then we had 4, then one of those 4 was eaten, so then we had 6, and then one of those bunnies was eaten, and then we had 10, and then one of those bunnies was eaten. So we had 9, and then they reproduced and they became 18. And then after 4 bunnies of those 18 were eaten, and so then they had, let me do my math real quick, we're getting pretty hard, 14. They had 28 bunnies, and then 20 were eaten, and so it goes on and on and on like that, and the bunnies are actually growing what we call exponentially until they reach a certain point. But then we see, as their bunnies increased, what we saw is the wolves increased because there was more food for the wolves, and then they would eat more of the bunnies, and eventually they would overhunt the bunnies and actually cause a decrease in the bunny population. Okay, this graph isn't going to do you much good. And user, there is that graph. So I had to edit this because you were originally supposed to be 20 rounds, and we only got through 2. So I definitely edited this so that you could finish it in the time of the classroom. But here's kind of what we saw. If we would have graphed it, it would have looked something like this. Now you've got time on the x-axis and size of population on the y-axis. And so we see our prey population, if we were to graph what the data that we found here, and we kept going a bunch of rounds, we would eventually see this cyclic pattern right here. Now this is the graphical relationship between predator and prey population. If you can see right here, as my prey population increases, eventually it hits a point. Now that's because when I increase the amount of prey present in a system, so if I have a bunch of bunnies, I am going to that's going to allow the predator population to also grow, and it's going to grow exponentially until it hits a point where the population of predators is too large to be supported by the prey population. So then they're going to drop drastically. So we're going to have an overhunting of the prey until they reach this critical point right here. Now, the population usually doesn't completely die out, because as we are decreasing this prey population here, the predator population is also, as a result, going to decrease because they don't have food. And then if they don't have food or the means to get food, they're eventually going to decrease. But when we have fewer predators in the system, the prey are able to have more babies. They're able to multiply better, and they'll increase, and then we get this cycle of predator-prey. So this is a super important graph, and I hope you understand it. Maybe I'll find some supplemental videos that'll also help understand it if me explaining it didn't help. But think, and especially if you did the lab, you should have a better understanding of this. But if my prey population is going to be able to grow when there are no predators, think your bunnies. So my bunnies, if there are no wolves in the system, my bunny population is just going to go crazy. with growth until something stops it, like an abiotic limiting factor, like the bunnies don't have enough food. But that's not what we're talking about. We're talking about bunnies and wolves specifically. When I enter a wolf into the system, at first it's going to have trouble getting food if there aren't a lot of bunnies in the system. So it's going to be harder to find them. They're going to be more camouflaged. There's going to be more room. There's several reasons why these prey can escape. But as the prey continue to multiply and have babies, because that's what they do, then my predator population is also going to have the opportunity to increase as well because there's more food available. Think normal things like a mama bird isn't going to have babies or eggs unless she can support her own self, right? Even if you think in humans, it's not a good idea to have a baby until you can support yourself and the baby. Predators are the same with less thought. You cannot have babies in a population unless you are having enough food that supports the adults until the adults reach the age of reproduction. And then as we increase our predator population again, they're going to get to a point where they start overhunting the prey. There's not enough prey to support the amount of predators. You saw that. So while a wolf might have landed on, say, just one bunny wasn't enough for the wolf to survive. It needed 3. So that wolf would have died. Good. That's about it. I'm going to explain this more on our Zoom call, so if you still didn't understand this, please attend our Zoom at 11 today. The link is on the Canvas homepage. All right, have a great day, guys. Your job is to answer today these questions right here. So these are your post-lab questions, and I might edit them just a little bit after looking at the data and what we were able to gather. There's 10 of them. They'll be worth 10 points. We're going to try to sketch the graph. If you didn't do your post lab, you can use this video to help you and their data that they found to help you. Just pause the video on the slide that you needed. What happened, actually I'm going to take number 1 out. So what happened to the bunny population when the wolves increased? What happened to the wolf population when the bunnies decreased? Does the wolf population ever outnumber the bunnies? Yes or no? For how long? If this is a period of short time compared to the entire section, what do you think? Question 5, how do you spell your teacher's name? Question 6, in this simulation, we choose to limit the total number of bunnies to 75. What might be limiting the bunny population in real life? Why can't the bunnies just grow exponentially? Look at the population plot generated. Does the plot, we're not going to do 7. What do you think would happen? That's a good one. If the wolves and the bunnies, if you introduce an additional predator like a coyote. Do humans have predators? And we are predators. Think of the things that you might prey upon. Okay? Good job. I'll take all those questions that you don't need any longer. You are good to go. Attend the Zoom if you still need help analyzing your own data. Goodbye.